This conference will now be recorded.
Hi all, so welcome to performance testing with JMeter Code to Master Level, and this will be day 5. Okay, so as a recap, if we see in previous day in day 3, day 4, we have talked about the HTTP protocols, right, and something related to that. So before we move ahead, we'll go back and to PTLC life cycle, the point where we started. Okay, so yeah. phase 3 and phase 4, right? So if you see uh, so in phase 3, what will be the first part? Identification and documentation of business and test scenario, right? What is business or test scenario? You got the idea, and the transactions involved in that, right? So what is the meaning of transaction? That also you got the idea, right? After that, we will be doing the recording, a script recording. It's basically recording or capturing the request and response for each transaction or user action, right? For a particular business or test scenario on any application. So this capturing, right? Capturing of request and response. You got right. What we will be capturing whenever we'll be doing one transaction, a request will be happening and we will be receiving response. So we have to record or capture that, right? So the things start with that. Then we do enhancement. Enhancement phase is little bit long phase. It involves correlation, parameterization, putting assertion, use of functions, writing some code, test data preparation, settings in tool, right, etc. Then after that, the script replay, debugging, and stabilization. And so just stabilizing the script. Okay, then phase 4 will start, right? Putting the user load and test execution. So in these two phase only, basically the tool is involved, NEPT tool is involved, and then after we execute, we get the result, right? So we analyze that, we prepare a report, we provide recommendation. If required, we rerun the test, right? So again, this all is human intervention. Okay, so you got the idea, right? What is the PTLC life cycle? Now uh, a transaction, right? So a transaction is a user action or transaction we got. Then see, in manual testing, right, people deal with test cases and test scenario in Excel, right? Because everything is manual. Same way in automation, we write some code, right? So we prepare a script either through Selenium with Java or Python or EFT or APM. Many things are there. So that is called as automation script. Okay. In performance, we use PT tool, and the thing that we develop, that is called a performance script, right? Script here. Okay. What is the meaning of a script? A script means a story using which the user will act, right? User will act like how we have a script for movie, right? Whenever anyone prepares the movie, so we have so director will give a script to heroes, right? Actors, they have to play the role like that. So the same word script means our user has to play the role for that, what the script is developed, right? So it is a script. That term is called a script. So we have performance automation script, we have performance script. Then in load runner is a PT tool, right? You will be knowing, we discussed it back. So C or JavaScript language is used, right? In 20 to 20% of cases. Okay. Uh, just give me 1 minute. I think your people are getting lots of background noise, right? Give me 1 minute. Okay. Okay, so right, so in that this language is used. In JMeter, we use Java, JavaScript, Groovy, or Python language. Anyone we can use. Basically, in our session, we'll see use of Java, right? So do not worry. Again, I'm saying, right, in 20% cases, use of language is required in JMeter. Only in 20% of use cases. Okay. Initially, for 70 to 80% of use, you do not need to know any language. Okay. So yeah, do not worry about that. Then this business or test scenario, right, and user load distribution or workload modeling. So right, so these are the scenario that we have seen, correct? Like a person logging, browsing a product, log out. Different on an application, there can be different scenarios, right? And whenever we run a test, we can run uh, let us say the client says, means client means the product for which we will be doing the testing, right? The senior management, let us say they want to run 1000 user load. Okay, so you can run a test on a single scenario as well, running it individually, or if you have to run multiple scenarios, then uh, depending on the distribution requirement, right, you can distribute the users through across each scenarios, like let us say 600 people doing the first scenario, 200 people doing the second scenario, 100 users doing third, and 100 users doing fourth scenario, right, like that. So in total, if you run total 1000 users will be there, right? So that is called test suite. So that will also see, we will see, right? Um, how to run multiple scenario at a time, how to run single scenario at a time, right? All these things we'll see. Okay. Now come to client side and server side and client side performance testing. Okay. So see, whenever user using a browser, right? Browser, obviously, using a browser, he browses an application, so he sends an request, right, and that request goes over uh, to the server or application, and from the server we receive the response, right? So that comes to the user, right, over back to it over the internet. Now whatever the things that happens on server side, server end, that is known as server side, correct? And whatever the things that happens on client side, that will be known as client means user here, right? Client has two meaning again. Client means user, and client has another meaning, like the product owner, right? Let us say you'll be working on some project, right? Who is the owner of that project, right? Whose project it belongs, so that is also called as client, right? So here client means user, correct? So what happens on the user end, that is known as client side. Now generally we do the server side performance testing. Okay, so what is the difference between them? So first let us understand. So let us say I will open flipkart.com. So I opened the flipkart.com, right? So a request went, correct? We know a request went. We can see that request over here, here. Okay. So this you can click on over it to get an detail, right? What is the request URL, request response headers, request headers, all the thing. And obviously a response will come. Response will be in code format. You see the code format. Or we can get this code by right clicking and clicking over here, view piece source. So understand, when the request goes from the user end to the server, right? Server entertains that request. It analyzes that. It decide what it has to send back to the user. So it will send the response, right? Response, correct response. response. Now this response always comes in code format. You see, code format. So the time taken, uh, the time, right? The time between this, like the request going to the server and response coming till this code format is reaching to us. This is called as response time. Okay, response time. Or we can say, yeah, generally it is called as normal response time or server side response time, but normally this is called as response time. And in this is what generally we measure in 90% of performance testing cases. Means whenever we talk about performance testing, it means that we talk about the response time from the server side. Okay, uh, uh, right? Yeah, server side, and that is what server side performance testing, right? So most of time we do only the server side performance testing. Means receiving the response from the server in terms of this code. Okay, code. Okay, so at that time, means till that what time it is taking, how many users it can support for doing this, right? User load, what is the behavior of my server. Let us say when I'm putting 1000 user load, 5000 user, that thing is tested, right? Now once this response come to user in code format, after that two more thing happens. Okay, two more thing happens. What is that? The embedded resources will be downloaded, correct? We have seen that so many embedded resources will be there. Yep, they will be downloaded. So the time taken for that, okay, sometime let us say t2, t2 time taken for that, and after that, uh, after all that has been rendered, so means all has been downloaded, then a browser will render that everything code and that embedded resources. So it will take some extra time, t3, right? T3. So these two activity is done on the user end. Generally it's done on where? On user end, right? User end. And this comes under client side performance testing. Okay, because it happens in client side. And as I said, many time people do not worry about that. Means people means the project owner, or in performance testing very rarely that is considered. But nowadays this is also getting famous. Testing from client side end is also getting famous. Okay, right. Many people, why they ignore? Because it is dependent on user machine. Okay, it's all related to user thing. Okay, means because it happens at the user, right? It is done by the browser. Many people focus on this as well, that hey, we should check from the client side perspective as well. So that is also known as UI performance testing. Okay, UI performance testing. You got the idea? Two difference here. Now coming to the approach. Okay, so this server side performance testing is very easily, it can be done using JMeter. Okay, JMeter. And in load runner also, load runner a very widely used tool. That means commercial tool, but very famous tool. There we use web HTTP HTML protocol. Their own protocol is there. Okay, in load runner, using that we do that, right? HTTP HTML protocol. Now, right, so generally in JMeter, from JMeter also we can directly do this server side performance testing, and we'll be learning all these things only. Now coming to the client side, uh, okay, so there is only one stuff that can do client side performance testing properly. That is known as true client protocol. True client protocol by load runner. Okay, in load runner only, which can do properly, means with best result, with best outputs, everything. Now you'll ask me, can we do from JMeter as well? Yeah, we can do with from JMeter as well, with little limitation. In JMeter, we have to use Selenium WebDriver. Okay, Selenium WebDriver. That integration with JMeter, using that we can do, right? But some limitation is there. Plus, you have to know the Selenium as well if you want to do that. Writing XPaths and the Selenium, some functions are there like dot click, right? Clickable element, click the X path. Some terms are there, right? Using that, so that also we have to know, right? So using this we can do JMeter and Selenium entry. So in our course there is one session in the end where I'll be covering like how this JMeter and Selenium WebDriver integration can be done and how we do a client-side performance testing. Okay, so that is also there. Now see here. So this is the general response time. Okay, the request goes to server and server respond to us in code format. The time taken, that is normal response time. Now this additional time which is done or which is taken on the user end is something different, and sum of total, right, this and this is called as end-to-end response time. End-to-end response time. Okay, but as I said, this part is generally very rarely consider, or depending on the requirement, few companies look for that, few people do not look for that. Uh, it do not come in picture really, but this is what we generally focus on. Okay, now some other tools are also there to do client-side performance testing. So in that session I have explained about that, what are the other tools related to client-side performance testing. All right, so this is what server side and client side. Right, since server side is important, so we will be looking means most of the course content is on the server side only. Okay, now we'll talk about the architecture, application or client server architecture. It's n type designs and they're different layers. So application architecture has basically three layers, okay, which are called as foundation layer: presentation tier, PL layer; logic tier or business logic layer; and data manipulation layer. What they do, we'll talk later on. Means soon, after few seconds, we'll talk. Do not worry. Then there are four types of application architecture. These are the layer. Okay, foundation layer. Foundation means like suppose we build a home, right? So we have foundation, then one layer, like two layer, like that, right? So application is also like home only, right? Home for softwares, right? Then there are different types of architecture. So one tier, two tier, three tier, and multi-tier. Multi-tier is an extension of three-tier architecture. Right? Many people call it as a n-tier architecture. Now let us we'll first understand about architect tiers, right? Then PL. They both are interdependent. The layers and the types. So first tier architecture. Okay. First tier architecture used to happen early in 1980 something or 1990s, when computer world just it came in picture, but internet was not there. First computer came, okay, then later on internet came. If we see the discovery, right, when first came, so first computer came, then internet came. There is long gap between. So at that time, everything, right, one tier architecture means everything is kept on single machine, right? Means all are you can say joined or kept on a single single machine. Nowadays this is not there, but still yeah, nowadays also we have uh, where we can see this. So in 8th semester when you prepare a project, right, so you obviously everyone have done, I believe, right? So we prepare a sample project, mini project, so we keep everything, right? We install the database, okay, we install other application related thing on our same laptop, right? And then we use it and we show it, or let us say we develop it. So that is what on a single system when we have done, right? So this is one tier. So now also it's there, but very at minute level it is there. Now two tier, okay, two tier is there nowadays, right? And so in two tier there will be two layers. That's why it is called two tier. So we'll talk about two tier a little bit more later on. First, let us understand three-tier, the now modern architecture. And nowadays, every application has this three-tier architecture. Okay. Then we'll revert back to two-tier. So three-tier architecture have three layer. Fine. What will be those three layer? The first layer is called as PL layer, presentation layer. The second layer will be called as BLL layer. Okay. The three layer that we just discussed. And the last layer, third layer will be called as DML layer, data manipulation layer. Presentation layer, uh, business logic layer, and DML, data manipulation layer. All these things are kept on different machines. They are not kept in same machine. They are kept on different machines. Okay, and they are interconnected. So let us say on machine on where the PL layer is kept, that is known as web server. Web server. On machine where the BL layer is kept, that is known as app servers, application servers. Okay, or app servers. And on machine where this database layer will be kept, that is known as DB layer. Very simple. Okay, DB servers, right? And these all will be interconnected, obviously. Where this is kept, that is known as data center. Okay, data, or we can say it's called infrastructure. Nowadays, everything, all this layer will be there, but now that will be on the cloud, right? Cloud means a few days back I explained, right? The infrastructure is given by some other people. We just use them and we pay them, right? Earlier, the infrastructure was every company was having their own. Now it's going to cloud, right? Means using their own. There are many uh, important feature of using cloud, because self auto scaling is there, right? And security is there. Many features are there. Automation, infrastructure automation tools are available, right? So you will if you are a beginner, you'll learn about them slowly when you enter into IT industry. Okay, so moving to cloud is a good thing, okay, because of the features they provide, right? But basically all is machine, right? You can say this will be one machine, one server. This will be another server. This will be another server. And server is what? It's a combination of hardware, right? CPU, memory, right? Memory. Then inside that OS will be there. Generally, most of the OS used in any server is Linux OS. Okay, in 98% cases, Linux OS is used. And these servers, and in that, inside that, a application server is there. Server. So what are the example applications here? There is one slide I have written there. Like you must have heard of Tomcat. Okay, Tomcat. And then WebLogic. Okay, these things will be there inside that. And then in that, the let us say the PL layer related code. Here the BL related code. Here the database related code, and all the softwares will be kept, and they will be interrelated. Okay, interrelated. Correct. That's what three layers. Now, what these layers do? So the first layer is called presentation layer. Why presentation layer? Because this is the layer which a user interacts with. Okay. Mm. Uh, like the look and feel thing that you see, the front end. So before I go and explain the difference, uh, this is also called as front end. You will get the idea. You must have heard of front end. This is called as back end. Okay, back end. And this is obviously DB, right? So front end, right? The look and feel which user sees, that is what the presentation layer. Okay, like if I open Facebook. Okay, so you see, let us say whenever any people visits Facebook, the look and feel, right? The page, the static page. Static means that doesn't change, right? For users, it remains always same. Wherever n number of user coming, uh, right? let it be 1000 or 1 lakh. This will be remaining same, right? This will be remaining same, or let us say for this ICS, this will be remaining. So, and this is look and feel as well. So this part is kept on the, this part you can say comprises the presentation layer. Then BL layer, as you said, it's a backend developer you must have heard. So the logical code means the code, you can say the code to do the logical activity is kept or is developed, or you can say is comprises in BLL layer. Okay, business logic layer. Name itself is business logic. Now, what kind of that logic? So, for an example, let us say when I will enter username and password, and when you people will enter your username and password and then hit the login button, so you will get your posts, right? You will get your friend list. You will get your messages. Same way, I will get my post, my message. So this uh, logical calculation, okay, to show what to whom, right? Remember, to show what to whom, right? Means which user I have to show what, right? To show what to whom, that, and many other thing like that. The logical code is uh, that processing main thing is kept here. Okay, or that comprises this layer, right? Same way, let us say if anyone open ICSE, so this page it will be common to all, right? Then he will click on login, and and then here let us say everyone will be logging, right? Let us say 1000 people logging in. So every people will have their own bank account statements, right? Everyone will have their different balances. Everyone will be having their own different pays account, beneficiary account. If anyone having loan, so he will be having that field, right? Like that, right? So you see, different people will have different views uh, based on uh, based on the activity or based on what they have done on with that bank, right? So plus, even let us say very simple example, right? Your balance will be something else, my balance will be some, my transaction will be different, so that thing, right? To show to what to whom, that calculation, okay, that is there in that thing is done by this layer. And we have DB layer. So basically DB layer is the, you can say it's a backbone of everything. Everything is data, right? At the end of the day, everything is stored in data only, database only. So it's a last layer and it's the backbone thing. Okay, data, everything is data, right? So everything will be stored here. And this is how the things works. Whenever a request the user interacts, first it interacts with PL layer, he will do something on that, and then that request will come to app layer, right? Or BLL layer, you can say app server or BLL layer. That will be processed, and then some, it will go to DB layer. Whatever that user needs, that information will be fetched back to this app layer, and it will be given via presentation layer to that user. Okay. And whatever these things goes on over here, that is known as that is what the server side activities. Now, few some languages, right? So the language which the common language which is used to develop the PL layer are like HTML, CSS, and JavaScript. Okay, the front end developer you must have heard. So they do that thing. Nowadays some other languages has came, like you must have heard of Angular, or you must have heard of that React, right? React, these things, they are part of JavaScript only, extended version of JavaScript. Then the backend, right? The backend developers you must have heard. So or the BLL layer, right? So that thing is done using the main programming languages you must have heard, like Java, PHP, .NET, Ruby on Rails, Python. Okay, so using this. And in the DB layer, the software used is obviously we know that many software, many Oracle, many databases are there, like MySQL, PostgreSQL, SQL Server, Oracle. Using that, the DB is developed and all records are kept, okay, in the DB layer. So this is the three-tier architecture. Now we have multi-tier architecture. Okay, so multi-tier architecture is the extension of three-tier architecture. Just a second. Yeah, so three-tier architect, you can say multi-tier architecture, that fourth one. It's an extension of three-tier architecture. In multi-tier architecture, what happens? Uh, Many components, like multiple components will be there. Multiple, you can say multiple servers will be there of the same layer. Like you can see here, multiple web servers, multiple app servers, multiple databases server, right? In middle, you can say load balancer is there. Then many things will be there. Uh, Firewall will be there, firewall also will be there, right? So every application has their own architecture. Okay, now why multiple here, multiple servers? So see, every everything, okay, everything in this world, or every stuff in this world has some limitation, right? Even you, me, has some limitation. Like, let us say I can pick 40-50 kg weight, not more than that. You can pick more or you can pick less, right? Everyone has limited. So same way, the hardware, the CPU, or this servers has some limitation. They can take a certain amount of load, right? So let us say there is a server, web server, which can take 1000 user load. Means 1000 users, if they are coming to the system and then they are browsing and everything, so it can handle them easily, right? That is its capacity. But if more than that it is coming, then what will happen? It cannot handle. So at that time, what will happen? The application will become slow. The application will start throwing errors. Okay, so, and requirement is that more than 1k user will come, right? So let us say total 10k or users are coming per hour basis on my system, and one server can handle 1k only. So what about 9k? So that's why we have multiple web servers, multiple app servers, multiple db servers. They're all interconnected, right? These all are done by infrastructure team. Then some other additional components like load balancer. What it does is it distributes the load, right? Depending on which server is free, right? So let us say, uh, let us say this is serving at 900 request, means 900 user it's serving, and this is serving up to 800, this is serving at 500, right? If more requests are coming, it will check, right, where which one is free. It will direct, right, those requests to those web server to handle, right? So that is what multi-tier architecture, right? Nowadays this is the multi-tier, which is just an extension of three-tier architecture. Now there is one more which came in picture, microservices. So microservices is nothing, it's just microservices architecture. You must have heard, like, uh, they are just extended version of this thing only. Okay, extended version. So if you understand this, later on if you read about microservices, you will get the idea. It's just an extended version of this the multi-tier architecture that we see, right? Okay. Before I go, yeah. So something I'll tell, like CPU, right? CPU. Let us say our laptop has a CPU. We generally ninth generation or 11th generation, right? 11th generation. Normal Pentium, Intel Pentium, Core i5, Core i7, or Core i9 will be there, right? But server grade CPUs are little bit powerful. Okay, they are especially made for more performance, right? They come costly as well. So they will be of Xeon series. Intel only prepares most of the server grade that CPUs, right? Intel and AMD will are two companies which produce, but Intel produce most of the server grade CPUs. So they will be, they are of Xeon grade, correct? Xeon there means more powerful. That's it. Okay, so yeah, this slowly when you enter in the market, in the job or in project, you learn more, you will get the idea. So that is what the CPU part is. And then inside that, obviously, as you said, OS will be there, then a server software will be there, and then all the components will be kept, right, related to that, the applications, right, in different layers. Software, whatever the needed software will be there. So same thing I've written here. So the presentation layer receives and displays the output. Application layer does the processes logic. It makes the logical and like it does, you can say, logical processing. And database layer, it stores and manages the data. Okay, so the same thing with more illustration, more diagram I have kept. Now we'll talk about thin client and thick client application. So, and then I'll come to 2-layer and 3-layer architecture. Okay. Then we have some diagrams. Yeah. So thin client and thick client application, right? So all those applications, right, which we access through browser, all those applications which we access through browser are known as web application, and they are also called as thin client application. Okay. Thin client application follows 3-tier architecture or multi-tier architecture pattern. In this, the layer 1, the PL layer, is on the client or user facing, but it's not installed on the user, right? Remember this thing. It's not installed, but the PL layer is on user facing, right? Means the user using a browser access the first layer, that is presentation layer, right? For thin client application or for web-based application, right? Using a third-party interface like browser. The two layer, layer number 2 and 3, BL and DML layer, are on the backend of the server, centralized. We do not have access, right? We interact with the PL layer. Now, thick client or fat client application. So all those mobile apps that we see, or desktop apps like train ticket booking clerk app or banking employee app or restaurant order accepting app, these things are all the example of thick client application. And thick client application follows 2-tier architecture. Okay, pattern, right? The layer 1, since it has 2-tier, means 2 layers, so layer 1, which is a combination of PL layer and BL layer, are treated as one layer, and it is on client side, means they are installed on the client side. Okay, they are installed. So what is this installation, what is this not installation, I'll give with the example. And there is no involvement of any third party interface to access this application, right? But here a third party interface is required, and the DML layer is on the server side. So the difference between thin and thick client are, you see, this is all web based application are thin client. The thick client examples will be this all stuff. Okay, I'll explain with all, do not worry. Thin client follows 3-layer architecture. This follows 2-layer architecture. In thin client, nothing is installed on the user end, and user interacts with the application using a browser with the PL layer. BL and DML layer are on the backend. Here, only 2 layers are there. The first 2 layer treated as one layer is generally installed on the client machine, and there is no involvement of any third-party interface. And DML layer is on the server side, centralized. Okay, now we will come to this diagram. So, so about 3-tier architecture, I just explained, right? Any web-based application follow the 3-tier architecture. Okay, a PL layer, then PL layer, then BLL layer, okay, and then DML layer, right? And any user accessing that, he will use a Chrome or any browser, right? Through that browser, he will interact with PL layer, and then this BL layer and DML layer things works. Now come to 2-tier. In 2-tier, only 2 layers will be there. This DB is generally centralized. Centralized. The example of 3-tier architecture we know, right? All web-based application are 3-tier. Now come to the example of 2-tier. So all the mobile apps that we download from the Google Play Store, right? Whether it is iOS or Android, it's followed 2-tier architecture. Why? Because it is installed on the device, right? You see, you download it, you install it. So few of the component is installed, right? And then you start using it directly. Let us say your banking thing, right? You see the software, whole software, you can say that is authenticated software is kept. Only the transaction that you are making that interacts with the database, right? But here, let us say I have a ICICI mobile app, and same way I have ICICI web app. right? Web application, ICIC web application I have just shown, right? So what is the difference in web, in the mobile app? The most of the component is installed in my device, right? I just log in, right? First time I have to register, and then once login and everything is done, then whenever I open, I'll enter the mpin. Everyone does the same thing, right? Any mobile bank it is. And then you go inside that, everything is in your hand, in your device, everything is installed. Only what thing changes, let us say your account balance detail or the statement will keep on changing, because that interacts with database. That is the data which keeps on changing, right? But other components is there in your device, right? It's installed in your device. But here that is not there. You are using a browser, using that you are accessing the application, and then you are doing the activity. If the browser is not there, you cannot do. Okay. So this is what they follow, the two tag. Same way other example, like you see a train ticket clerk booking app, bank employee or restaurant accepting order app. So they also follow two-tier architecture. These are also known as desktop applications. Okay, desktop applications means, let us say I'll talk about train ticket clerk app, train ticket booking clerk app, right? So the not that agents, okay, not agents I'm talking about. The real employee in at railway counter, you will see who are booking the ticket. So they do not use IRCTC. We have IRCTC for booking the ticket, right? That is for normal user. For us, it's a web based application. But those people, the clerk, they do not use IRCTC. Okay, they have some other application. You must, many of people will not be knowing, because right, because nowadays I believe everyone is booking through IRCTC. But the old means a little bit, those people who have gone to that clerk maybe in lifetime, they know. You see, it will be a dark screen, and through that he will be booking the ticket for you. Okay. Same way, the any bank employee, okay, same IRCTC example I'll give. IRCTC bank employee, let us say, or any bank employee, if you get a chance, if you visit, you just try to see their screen. Okay, they will not be using the application that you use. Either it will be web version, let us say I have SBI, or I have ICICI, or I have HDFC. All have three kind of versions. Okay, one is web version, the website that we say. Then mobile version, that user installs in mobile. And then employee version. Okay, employee version is totally, it will be looking different. You can just go and check it. They will not be using the web version that we will be using. They have different, so in that, some part is installed in their desktop, and that is secure. That's why in this lockdown also, they were not allowed to do work from home, because they cannot carry it to home, right? It's very secure machine on which they are working. Okay. Same way, this the food order ticket, sorry, food order accepting the software. Okay, so let us say you are ordering a food through Zomato. So Zomato has also three versions. Okay, one is web version, you can book through web. One is mobile version, you can install that APK, and you can, and one is the for those service provider. So that you can see, like in few months lockdown will be over, so you go, even a nearest restaurant is taking order nowadays, so you can go and see the screen. Okay, you just peep to the screen, just try to see the screen. He will not be using the web Zomato that we used to book, or the mobile. He has some different software. Okay, some different application he'll be using. So that, in that, what happened, the things is kept. Okay, it's kept on his device. So that is what it's installed. Okay, it's installed on the device. Again, hence those desktop apps, they are also called a desktop app or mobile apps. But for thin client, nothing is there on your device. Nothing. A third party interface is there, using that. Other desktop apps have the all other example also. So just remember that if it is kept on your device, if it install your device, it comes on the T client application, right? Okay. So that is difference between two-tier and three-tier architecture, or thin client and thick client applications. Now here one diagram, like how multi-tier architecture works. So you see a little bit complicated architecture. So here three layers are there, right? Yes, so many database are there. Then here these are app servers here, and here web servers are there, and there here external users are there. Here here internal users are there, internal users. So for the external user, whether he uses through mobile or the PCs, right, request will be going through firewall. Then this is the switch, right, with transfer the request, and this is how it goes to app server DB, and then response is returned back to him. And for the internal users, since they are authenticated users, like as I said, the bank employee, right, they are authenticated, they use different software, right? So they will be their entrance will be little bit different, right? But they will be having also same kind of right, but few components will be removed for them, and this is how they will be interacting. Now few examples. So see, any application that will be working has some architecture. If you wish, you can ask your team for whom you will be working, that ask that what is the architecture or what is the blueprint. It's better to ask, like, because interview they ask. So suppose you are attending an interview, so they will ask that, hey, what is the architecture, what was the architecture of the last project that you are working on, or current project you are working on. So architecture means you have to explain about the software component, the hardware component. Okay, generally they ask about software component. Hardware generally do not focus. Software means like what layers will be there, and on which languages or on which technology it has been made, right? On which languages or on which technology it is made, right? So they will ask, like, so that is all. So one example here, let us say the EY layer, the presentation layer, is also known as EY layer. So it is being made on Angular JS and .NET framework, and it is hosted on IaaS servers. Their application servers are there using that, and this is kept on Windows Server 2012 OS. OS is Windows Server. In most of the cases, Linux will be there, but here Windows is there. Okay, in this example, then business logic layer, right? That is developed in .NET language, and then we have database. Database is SQL Server 2014, and this is how they are in Microsoft, their Azure cloud. Okay, it's cloud. So this whole thing is kept on Microsoft Azure cloud. Now, in same way, another example, little bit. This is for AWS, right? So we have different cloud providers. I told right few days back. We have Microsoft Azure, we have AWS, Amazon AWS, we have Oracle, we have Google GCP. Okay, this is AWS cloud. Okay, means cloud means what? Remember, infrastructure thing is given by just different people. We just pay and buy the infrastructure. uh, Infrastructure means the hardware basically. Okay, and the some software needed, that all things will be given by those people, and we will be putting our application related code and other thing on those, right? And we'll be using as many servers as well, right? So here just we do not worry about in-house thing, means those setups being made in our company, any application, he do not bother about. That is what cloud and the earlier architecture, there is no such difference. Okay, cloud nothing is special. It just the infrastructure, the data center you say is provided by some other people. We buy their thing, right? We buy the CPU, we buy the hardware. Okay, and we buy other some softwares with their plan, and we keep our application, do the setup, and then application is being used. Okay, so this is in AWS. You can see here the first layer is web server, right? It's on Windows EC2. It's like it's on Windows OS, and in middle layer load balancer is there. Then here application server is there, app server. I think it will be looking little bit small, but Air app server. Okay, it's on Linux. OS is on Linux, right? One backup server is also there. Here also load balancer, and then some other services are there related to AWS. And then we have you see the primary DB as MySQL, and then secondary DB, backup DB are also there as uh, MongoDB. Okay, MongoDB is one of the DB only. Now it has came like how we have Oracle, MySQL, MongoDB is also there, right? You see different layers, right? And this is how the users communicate. The user accessing through web application. He comes through internet, then come to web server, then from the request come here, then here, then goes back, response goes back. A user who access it through mobile app, so obviously for him this two layer become one layer, right? You see, as I just discussed. So you see the for him the request directly comes over here because the component, few of component will be there on that fellow, and on that fellow device, right? And this is how directly it comes here. It accesses the DB and some logical communication happen and response goes back. Some other systems are also there. Yeah. So like this, the architecture you have to know, right? It's good if you know because that is asking interview like, can you tell me the architecture on which you are working? Now, one thing I forget here to explain that DB is centralized in every, either it is 2 or 3 layer. Why DB is centralized? Because DB is an important thing. Centralized means it's kept at separate location, right? Centralized, you can say. Why? Because let us say the same example. Suppose that ICICI banking employee, banking, ICICI bank employee, right? They are using some other app, as I said, right? Two-tier architecture app that is also known as desktop app. Now, if you go there and you say that, hey, put 10,000, deposit 10,000 in my account, you submit a check and you say submit 10,000 in my account, so he will do that. Later on when you reach your home, you can open your ICICI through web app and you see that, yeah, 10,000 is credited. So how this happened? Because that fellow, he does that and he pushes that thing uh, to that DB. And since this DB is connected with everything, right? It's because the DB part is same. So whenever you are also logging in, you see that, yeah, 10,000 is there in your account. That fellow has deposited, right? So that's why, or let us say, as I said, the IRCTC example, right? The railway, uh, the banking, railway ticket booking clerks, they book through a different software, but even they will book, you'll see the ticket is going less, right? And if you see through IRCTC, we people, right, we book through IRCTC, we also see that ticket is going less, right? It's reducing, right, every day or every day because the DB is less, right? DB is same, and for that train, we see that the since the DB is same for that particular train, you'll see that the ticket is getting reduced, right? Whatever the interface is, DB will be same. Okay, means it's just common for any user, whether he uses a two-tier architecture or three-tier architecture, whether he uses a mobile app or a web app or a, separate dedicated app. Okay. Now, why an application becomes slow? So, an application becomes slow, or the why? What is the importance of knowing the application architecture? Like, see, the application can become slow because of many reasons, right? As I said that suppose there is here only 5 web servers are there, right? And they have some limited capacity and more load is coming, obviously they cannot handle, so application will become slow, right? Then if there is problem in the coding that developer has written in any of the layer, obviously the performing of the actions will not that much efficient, right? Then same way the everything is DB, right, database, so some queries are there, right, which are written to access anything from the database. So that database developer, the DB admin we say, he must have not written a good query, and hence the when the user or the this request is coming and trying to fetch something, it's taking very slowness over here to fetch that information and deliver it to that user. So that could be also issue. Then there will be, as I said, hardware related issue, software related issue, Then the setup related issue, right? Setups are not proper or not done, not configured properly. So because of this, any application becomes slow. And it's important to know the application architecture so that we should have an idea, right? Whenever you are hitting, where is the problem? Okay, where is the problem? But generally, this excess, right, or thing, you will initially, when you are going to do performance testing, you will not be having this, because senior people have this, right? So when you grow in your career, right, you become tester, then performance tester, then uh, APM expert, right, then performance engineer. So initially these things are, you see, in many company, right, in every many project, you may be having access to monitor what is happening here. In many project you don't have. Okay, other team, like DevOps team, will be monitoring this, or they will be looking into. So it's all depending on different projects. Okay, so do not worry if you see that, hey, I got assigned to a project to do performance testing, I do not know about that. It can happen. So do not worry. So now coming back, so what we have concluded till now, or what we have learned, is that there is an application. On that application there is a scenario, right? You see, and there is a multiple users, many users doing that scenario. And whenever they do each scenario, that scenario has a user action. That user action is termed as different transactions. Whenever we do that transaction, a request is being made. That request is of HTML type. Apart from that, other resources are there, the embedded resources. Okay, and it hits the server, right? Server is of, generally server comprises of two things. The hardware part, here you can see the CPU, memory, network, disk, hardware, and on top of that the OS will be there, right? OS, and on that application will be there, right? So like that, this thing is done. So I think that is for today. Hmm. Yeah, that is for today. But tomorrow we'll enter into JMeter. We'll talk about these things and we'll see recording. Okay, so thank you.